Hi friends, Miss Quist here with another example for you. Just a recall of yesterday's learning objective. It's to solve systems of equations using the substitution method. And again, this is still a continuation of page 19 for those of you using Interactive Notebook in my class. Our language acquisition objective is to explain how to find a solution of a system of equations by substitution using academic vocabulary. And then our essential question is, how do we use substitution to solve a system of linear equations? So, example number 3. I know we skipped example number 2, but that's just how we roll. So example number 3, systems with infinitely many solutions or no solutions. Says, what is the solution of each system of equations? So here are some steps. They're kind of continuation of last video steps, but with a little bit of a difference. So number 1 is still to substitute the expression from the isolated equation into the other equation. Step 2 is to solve the equation for the remaining variable. Okay, what's going to end up happening though in this video is something unique where the variables actually end up canceling out. So we have these little additions to our steps. If step 2 results in a true statement, example, 5 equals 5, meaning a 5 always equals a 5. $5 bill always equals $5. So that's a true statement, which means the system has infinitely many solutions. I ran out of room. Sorry, guys. Okay, so then step 2, if step 2 results in a false statement, example, 5 equals 7, then the system has, well, does 5 ever equal 7? Well, if you have a $5 bill, it will never equal $7. It just won't. So that means that there will be no solution if you get a false statement. Okay, so I'm going to do number 1 and number 2. Number 3 and number 4 will be your try-its. Okay? So let's do number 1. Y equals 3x plus 1 is our first equation, and our second equation is 6x minus 2y equals negative 2. So from yesterday's video, I know to take the isolated, the equation with the isolated variable, which in this case is y, because y is by itself, and I know that y equals 3x plus 1. So when I come to the second equation here, instead of writing y, I'm going to write 3x plus 1. Everything else is going to stay the same. Just like when you have a substitute teacher, your classmates and the class and everything around it still stays the same, except for the teacher. So in this case, the y is going to go away, and we're going to write what y equals. So 3x plus 1. Then I'm going to put the rest of it, equals negative 2. These two equations are the exact same, except for this one says y, and this says what y is equal to. Now solving equations, I need to first distribute. That's a rule from solving equations in topic 2. So I get 6x, and then negative 2 times 3x is negative 6x, and negative 2 times positive 1 is negative 2, equals negative 2. Okay, so then I need to combine like terms. When I look at my like terms, I know that 6x and negative 6x are indeed alike, and that means they're going to, 6 minus 6 is 0. That means they're going to cancel. They're going to go bye-bye. So these cancel out, and I'm left with negative 2 equals negative 2. Okay, so we knew this was going to happen because I, spoiler alert, told you at the beginning of the video. So we need to see if this is true or false. So is negative 2 always equal to negative 2? Are they the same? I think it's true. I think negative 2 always equals true. So this is a true statement, and if it's true, that means it has infinitely many solutions. All right, let's do number 2. So we have number 2. We're going to look at the problem or the system and see what is isolated. I see that the y is isolated in the second equation. And I know the variable that's isolated is y, so I'm going to plug in for y with this 5x minus 4. Everything in the first equation is going to stay the same. So I get 5x minus, instead of y, I'm going to write what y equals. I'm going to put parentheses around it just like I always do. 5x minus 4. Then everything else stays the same, equals negative 4. Okay, distribute. Now, believe it or not, there is an invisible 1 in front of that guy. So we're always going to distribute. And this is negative 1 times positive 5x, which is negative 5x. And negative 1 times negative 4 is positive 4. I'm going to bring down this 5x equals negative 4. Well, now we're going to go into combining like terms. I see 5x and negative 5x. Those are opposites of each other. I know that 5 minus 5 is actually 0. So that's 0x, and 0 times x is 0. So these cancel out. And I'm left with 4 equals negative 4. Well, let me ask you this question. True or false? Is having $4 in your pocket the same as owing someone $4? Well, I hope that you're yelling at the screen, because it is not. This is not true. Having $4 in your pocket is not the same as owing someone $4. It's not the same, so this is false. And if it's a false statement, then it has no solution. All right, so now you need to try number 3, and then you need to try your chunk summary. And then I will see you in the next video. Bye, friends.